Hello, Marco. Nice to see you.
Hey, Young. Great to have you here.
For those of you in the audience may not know Marco, Marco is a professor for robotic systems at ETH Zurich or ETH Zurich since 2015. His research interest lies in robotics of mobility, interaction, capabilities around that. And you co-founded also ANYbotics in 2016, and then your team won the prestigious DARPA Robotics Challenge, which helped also put ANYbotics in the map on 2021. So let's dive into how you bring robotics to the wild. And Marco, so please introduce yourself to the audience and let us know what brought you to this journey in academia and robotics.
Okay, so quick introduction about myself, Marco Hutter. I started actually as an ETH student in 2004. I was very interested in mechanical engineering. I was interested in building systems. I was interested in controls. And then towards the end of my studies, the question was like, how does that all come together, and what would be a nice way of finding a new application? And back then we started to work with single legs, and then later on with quadrupeds, which actually went on with my PhD journey. So I was interested in making mobile systems. In the beginning, it was only about how the heck can we make a system walk and move around, and what does it take, what kind of actuation do we need, what kind of sensing do we need, what kind of controls do we need, before we actually figured out, well, there's actually a big value to having systems that are highly mobile, and that's kind of the beginning of ANYbotics in 2016.
So, often most people hear about, let's say, Boston Dynamics and others that are running around and has some really good, let's say, media coverage. But in reality is that it's not deployed in any way in high volume today. So it is something that you want to solve, or tell us more about where are we with two-legged robotics or four-legged robotics, and what are the differences?
I think for a long time, the mobile robotics market in our daily environment was nowhere. I mean, how many robots do you see in your environment? You have maybe your vacuum cleaner at home or a lawnmower, but that's it. Yeah. So if it comes to more complex jobs, it's not possible. And I think we saw a bit of a transition in the last 3 to 5 years, where suddenly quadrupedal system went out of just labs and being simple prototypes into products that are ready for deployment in harsh environments. And certainly Boston Dynamics has played a pioneering role in that. Also ANYbotics, maybe a bit in the shadow in the beginning. We were highly driven by science and by research in the beginning, and only later focused on a clear market, on a clear product, and then very early on took this aspiration of going into industrial inspection with these quadrupeds. You said about small volumes, and yes, it's true. We're talking about hundreds and thousands of machines. It's not the volume that we have with industrial manipulators, which are in the hundreds of thousands. But still, I think it's something which, if you look at the growth rate, we are only at the starting point of having many machines in all kinds of different applications.
So if you project, let's say, 10 years out, let's say, and if you think about the future, how do you see the autonomous robots playing as a part of humanity?
Well, it's a super hard question. I think all predictions are wrong most of the times. And for sure, we are, from the research point of view, we're kind of over-optimistic. If things once work in science, it still takes quite a while until it's deployed in the real world. But what we have seen in the last couple of years, also with merging the developments in robotics and what came out of the AI community with machine learning and robotics together, we saw tremendous progress. I think if you just look back the last 6 months, there were probably like 8 different humanoids released, which are not like $1 million machines that nobody can afford and only a few research labs have, but really something that people can start buying, people can start building upon, and people can actually start thinking what is the applications and what is the markets. And I think that's the biggest challenge for us in all mobile robotics. We have to build the systems, we have to build solutions, and we have to build the markets at the same time. It's not that that's the problem and we just solve that problem which was already there with a new system. It's really coming together, like building up markets, building up solutions, going hand in hand.
So if you think about autonomous, right, we often think about autonomous car. In a way, autonomous car is also a robot
Absolutely.
and has a similar kind of nature of technologies and perceptions and controls and the paths, navigation action and action plans. So tell us about when you were building this beautiful ANYbotics, which you've been working on this for many years now. What are some of the iterations that you have to go through, and how does technology play a role in evolving this type of machines?
Yeah. I mean, here we're talking about the 4th generation of animals, and we did 2 generations prior to that. So it took us about 6 generations of machines to get to a level where this is a certified product that can do some work autonomously. But autonomous is not autonomous, right? So there's, depending on what you want to achieve autonomously, you have a different level of autonomy. And I think in the biggest difference to autonomous driving is that we are working here in a highly unstructured environment with potentially completely uneven grounds. We have these machines being deployed in the forest, where you have to go through vegetation, where you have to understand whether this terrain in front of you can traverse or not. So the challenges are much bigger. At the same time, the reliability of systems to never make kind of go wrong are much lower than what you have as a requirement for autonomous driving. I mean, if you kill somebody by autonomous driving, that's going to destroy a complete industry. For us, this is much safer systems. Maybe they fall at some point and they get up and continue to operate. So we have different challenges in that sense.
Very interesting. So often when you're designing these systems, I'm sure you do a lot of simulations to see the corner cases and others. But how do you make sure unknown corner case is observed and be able to detect and being able to anticipate? That seems to be the real challenge for, the reality is it's not like car where there's a road conditions you can deal with.
Yeah. I mean, this problem goes in many dimensions. One dimension is the design, what is the right morphology for the systems, and the other dimension is the control. And these 2 things go hand in hand, and as you say, like simulation plays a very important role, and even more so since recently, where we use machine learning for this, for designing controls, but then also to use this in a closed loop system to adapt the morphology of the system. So today we're able to generate randomly different types of environment. We can also take real world data for that and then adapt the robot morphology, so the way how it looks like, how tall it is, what link length it has, how much torque it produces, whatever. We can optimize this as part of this simulation pipeline where we continuously figure out what is the right controls and what is the right morphology of the system.
So in a way, you're injecting a lot of noise or disturbance so that you can be able to learn from that and then being able to have this input-output relationship with the feedback and being able to improve, anticipate potential changes?
So noise is one aspect to it. So what we want to achieve here is a system that is robust to all kinds of variations it might see in the real world. So that means, first of all, we try to understand what the real world is and bring all this different variability into the system. Now, some of these variances the robot itself sees. So it can map the environment, it figures out what kind of obstacle it has there, it can adapt to this. Some of that might not be sensible, so it's more of a disturbance to the system. So think about, you have a soft object, you see this and you step on it, it behaves differently. So you have to be robust against this. That very often you generate through adding a lot of noise, adding a lot of disturbances to the system. And at the same time, you have to be versatile enough that you can cope with different types of environment and that you're trying to be as optimal as possible to all these different types of environments.
So when I look at machine like this, robotics like this, clearly the sensing mechanism have to be real, and then you have to process it. So tell a little bit about for those engineers out there, what's playing? Is it LiDAR, is it camera, and then what kind of a compute and the AI engine that are there to enable this type of navigation?
Yeah, I mean, the system that we see here is equipped with 2 to 3 computers. It's like your laptops that you have in a beefy laptop. We have Jetsons inside with certain GPU compute power. Then there's a bunch of sensors. So we have a LiDAR on top, which is actually an automotive-grade LiDAR. We're doing about 500,000 distance measurements per second, which we then accumulate to a full 3D map of the environment. Then in the front and the back and on the side, there is wide-angle cameras plus stereo cameras that allow us to get depth perception of the environment, but also RGB perception of the environment. So we're looking at the geometry, but we're also looking at its appearance and hence the semantics. So we try to really understand not necessarily exact physical properties, but still how does that behave when I'm walking over this or when I'm interacting with that. And all of this sensor information is collected and computed on board the machine. So we do all on the edge. So there is no cloud computing for this real-time necessary data processing.
So this is a great example of edge processing applications. Is that because you're doing in a mission-critical environment that are potentially not connected and you don't want to rely on the connectivity to drive your mobility?
Yes, so there's certain stuff that we can clearly outsource to cloud compute, but this is typically not time critical, it's not stability or safety critical, but everything which is related to locomotion, navigation, understanding for whatever I have to do in my behavior is locally on the edge.
I mean, I love your mission of really, how hazardous conditions where humans may be exposed to chemical, environmental, different, maybe even dangerous fire hazards. And by creating actually machines that can be able to autonomously navigate and being able to inspect and being able to maybe even control certain things seems to make a lot of sense to me.
Yeah, absolutely. I mean, when we wrote the first grant proposals, when was that, like 15, 20 years ago, we're talking about search and rescue robotics. And obviously we're far away from that, but I think it paints a very nice vision, both for the technical challenges, but also an ambition of what kind of application we want to achieve. So we want to make machines that can help us humans in dangerous environment, in dangerous zones. We are doing every year, still today, we're doing a lot of tests with first responders, with search and rescue teams to figure out what can these machines actually do in these most challenging conditions like collapsed buildings. You have a fire, you have to be fast, you have to overcome obstacles. But I think when you're talking about business and business applications, this is a niche thing. And if you start the business based on search and rescue robotics, I think this is not very successful. Right. But at the same time, there's so many other applications where we are putting people at risk for doing a job, whether it's on mines, underground, 1,000 meter underground, whether it's like in offshore facilities or other situations where we can have systems which can take over some of these works and by that also protect us humans.
Now I understand this robot. By the way, Walden Catalyst is very proud to be part of and leading the last round with ANYbotics. I think it's a $50 million round, so there's enough financing to get the company continue this journey. But one of the things that we liked about it is that it is uniquely positioned as a certified for certain conditions. So maybe we can talk about what are some of these conditions that robots can handle where others may not be able to.
Yeah. So when we started to commercially build quadrupeds, one important aspect was like we have to make it robust for harsh conditions. So that started with making this IP rated. So these are IP67, they can dive a meter underwater for some time without being damaged. Then later on we realized that for some applications, or very often, we are requested to work in potentially explosive environments. So there came up the request for ATIX certified. And not this generation that you see here, but the similar type robot is actually certified to work in explosive environments. And I mean, that speaks for it, right? So you don't want to send people in these environments. You want to send robots that can take over this work.
Now tell me about this four-legged or two-legged versus the drones, which often people talk about for some of these applications. What are the pros and cons in your view, given the way I look at it, both all robotics and just different forms of robotics?
Yeah. I think it's really depending on the application you're looking into. If you're comparing just ground robots and drones, drones obviously have the huge advantage. It can go anywhere without having contact with the environment. But at the same time, they're super limited in their flight time, maybe 10, 20 minutes. If they're bigger drones, maybe half an hour. And also in the payload, sensory payload. So how much weight can you carry? If I carry a lot of weight with these drones get big, and then it's also a hazardous object. So very often regulations tell us that you're only allowed to use mini drones, and then you're bound to using a camera, and that's it. With these guys, we can walk around for hours, we can carry tens of kilograms of payload, and that really allows you to do very different work. And I think if we're extrapolating a little more in the future, we're looking at a future where there's not only robots that are observers of the environment, but we want to have robots that are actors that interact with the environment. And for this, you need to have force, and you need to have something that is a little more powerful than just a drone.
Great. So it's very interesting how this whole robotics area is evolving. And obviously, we're very early stage. Would you say we're in the, like, I don't know, baseball analogy? Maybe it doesn't work for you guys.
Yeah.
Maybe football analogy.
Absolutely, yes.
Yeah, first half, second half, or maybe first quarter. Where are we?
This is like in the absolute infancy. I think like robotics in general, like with the industrial automation and stuff like that, I'm not talking about this. I mean, there we are very mature, it's a mature market, and we could not imagine this type of economy and welfare that we have without this. But if you're talking about mobile systems in our daily environment, I think there we're only at the very, very early stage. These machines are still very stupid. I think if we are moving forward, if you're making them a lot more capable, there's tons of applications they can take over for us.
Great. So maybe you can talk a little bit about what's going on in this great robotics lab.
I think the broader vision of the lab is along the lines of what you said in the beginning. We want to make machines that are able to move and to interact in highly uncertain and unstructured environments. And that's one morphology of that. You can also upscale or downscale this. So we're working on large-scale construction equipment or forestry equipment that if you look at this today, this is like these machines, they are still operated the same way as they were like 20, 30 years ago. You have a nicer cabin, you have a better AC and a nicer radio inside, but the systems are not a lot more capable. And I think that's where the controls, the autonomy, the intelligence of what we develop here in robotics can make a big difference. Automating construction, automating forestry. We're working towards space. And I think also in space, there's a transformation that is happening. We look back to very fancy robotics that is used, but with very old technology. And I think now having it much more affordable to send payloads to space, people are taking more risks. We are using much newer compute, much newer algorithms, and that suddenly opens up a completely new market also towards space. And I mean, there's probably a long list of such things that I could tell you.
Exactly. So clearly it's a very exciting time, but there's always like two questions comes out whenever you have a machine and man. And sometimes you, of course, interact and increase and expand capabilities. But one question always is, does it take my job away, right? That's one element of the question. And the other one is also the ethics of the machine, right? What are the ethics around managing, autonomous cars that are coming down? Does it make decision about, who it hits to avoid certain things? So we're dealing with these realities that are probably real rather than hypothetical now. So what is your thoughts on those?
Absolutely. I think these are very important questions we have to answer, not just ignore. For the first one, about taking my job, I think it is a challenge, but not something that I'm worried about. Very often, people from a very high level and outside perspective say, oh, this guy is taking my job. But then we're looking at the jobs that we're actually doing, And all these skills, they don't find people anymore. So you go to these companies and they say like, bring me people. I have here, for example, a company, a Swiss company that does plastering of houses. And the guy came in the last couple of years, every couple of months, he came and asked me, why can't you build, please, a plastering robot for me? I don't find people anymore that do these jobs. I think there we are much more responsible to make machines that satisfy the needs that we have as humanity in the future. On the social side, I think it's important to understand that technology moves fast. And that means it is challenging for society and humanity to adapt. If there's quick changes, it's not so easy to. And I think there we have to make sure that we're also communicating the right way, that we are making sure that we are implementing this according to all the necessary standards, and that we as a community, we also define these standards. I think it's a chance for humanity, that it's not only one person doing something stupid and nobody can be responsible because that's one person, but we can have a society that defines regulations, what type of systems can do what and under what constraints. And the same also applies to warfare. I mean, it's a permanent question like, we see this robot doing some fancy stuff and now this is the next killer machine that comes and runs after me. Of course, in principle, these kind of things would be possible. And I think banning technology is just not a solution to solving this problem, but we have to make sure that we understand the capabilities, we're able to predict the capabilities of what will come in the future, and that we find the right regulations in order to use this for the good. And that's the most important thing. I very, very strongly believe that what we're creating here, and I'm not talking about quadrupeds in general, I'm talking about robotics as a whole, we are creating so much good that some of the bad thing we have to accept to happen, but it creates a lot more.
I mean, basically innovation will continue. The question is really how do you manage, right, in the new reality that we're going to live with, and you have to be one step ahead, I think what you're saying, so that we can anticipate. So now when I open your LinkedIn, it said professor and entrepreneur. So clearly you're doing both very successfully, but must not be that easy. So tell me about why did you also become an entrepreneur?
So for me, it was always important that what we're doing in research doesn't end with a paper that 5 people read and then it's done. And then you make the next paper and the next paper, but without having a big connection. We are trying to do things which have a longer-term impact. And the beauty about robotics these days is that we don't have to hunt for the problems and try to find these other niche problems. But the problems are so big, and all of them have, or many of them have applications out there that we can really shoot for big things which have a continuation beyond pure research. And that's how this entrepreneurial spirit came together. So we could, also thanks to a great team, great students, spin out certain technologies and move on. And actually the nice thing for me as mainly as a researcher is that these things are coming back. So we can do much better research because of better systems that are developed by our companies.
In a way, it helps, right, to improve your research. So tell me about your journey as a professor and entrepreneur working in number of these projects. What are some of the difficulties you have to deal with when you are managing the both sides of the equation?
So the question is like, is this a question to me or to the environment? And the environment would always say like, there is mixed interest, right? On one side, you want to make a company successful. At the same time, you should push your research, and these two things don't go hand in hand. There's a conflict of interest. I don't see this.
Actually, in America, I don't think that question comes out.
But here in Europe, it comes.
So that's why I asked the question, because we are in Switzerland,
yes.
And I understand that's more severely looked at.
I think it's important that we are looking at it, but at the same time, I think these two worlds, they profit massively from each other. And if you're just isolated looking at research or at making business success, I think that's not helpful. That's also the way how I see how companies in robotics can grow and can have a very or a high potential future by not starting with a pitch deck to solve a problem, and then figure out on the way, oh, actually, these are all these technical issues that we're encountering, but we have promised this, so we have to just run more and more and more and raise more and more money. But to start from building up ground technology until you have a very solid basis, and then focus it on certain applications and commercialize it.
So in a way, you're creating robotics platform that are really based on the control, the path finding, and other learning capabilities. And then you're applying to vertical solutions that might be able to solve difficult problems that humans may encounter. That's kind of what you're trying to do, right?
To some extent, yes.
Yeah, that's great. So a lot of leverage around that. So if you have to build your great platform, what are some of wish lists? Let's say, like compute perspective, I don't know, in actuator perspective, the edge processing perspective, or even training perspective. What are some of the key things you like to see in innovation from your ecosystem that you're depending on?
I think we are, being engineers, we understand that we're living in a world with incremental changes on these technologies. It's not that we're going to have this huge leap and something new comes in that just destroys everything. Conceptually, we can do this, but on the hardware side, on the motor side, on the sensor side, there's a continuation of improvement. And it's moving fast. I mean, when we started with these machines, the first LiDARs, they were this size, and they cost us 150K. And now we get this size for like 2K, and it's doing much better. And that's a short time period. And it's the same for the compute, and it's the same for the actuation. So I think we're seeing the right gradients. And by having more people, more industry focusing on this will be just more and more accelerated. But like this huge jump in something completely new, I don't expect.
Are you surprised by the whole AI topics that we're discussing now? Clearly, companies like NVIDIA, in a way with their GPU and their investment in framework, really took very strong position in enabling the whole large data set, AI system implementations, and in a way you could say it's predictable, but in a way what they have done isn't just compute. On the top of compute with a compilers and the framework and the algorithms, things were really multiplying each other. So do you expect it to continue, or how do you see that trend?
Totally. And I mean, this is also something where kind of research and industry, they went hand in hand. And it's super important for industry to permanently understand of where are the next steps coming from the research side. So to give you, or to go into this example of NVIDIA, when we started to really apply AI for controls with these machines, we started with our own simulator platforms and applied our own machine learning pipelines to that. And at some point, we also established very strong links with NVIDIA, and through these conversations and through their progress and through our progress, there was a much better understanding of like how can these simulation tools, they have to be shaped, how can these learning pipelines be adapted, and how can all of that accelerate robotics. And clearly they have a super cool pipeline with the compute to the software, but it's not a robotics company. I think that bridge is still happening through many companies that are using it.
There's the tools, and then you're applying those tools to make it work.
Yes, and we're not only waiting for tools to be there, but we are like continuously shaping the tools. So we are active developers of these things.
Absolutely. So are you using the open platform? Because often nowadays, so much of what we develop is coming together. So how much is open and how much is closed in you're looking at robotics ecosystem?
If you're looking back in robotics, I think the big transformation happened with ROS. So ROS enabled many people to develop their own thing, but share it with somebody else and make these things compatible. And we are trying to lift this. We're trying to open source most of, at least of the useful software that we're developing. A lot of our software infrastructure for machine learning-based control for the whole reinforcement learning pipelines and simulations that we kind of pioneered to some extent in our group, is now kind of a baseline for many people to use. So this is public knowledge. It's our main driver. We generate public knowledge, and people are using it both in the research area but also in the commercialization domain.
Great. So tell me about yourself when you're young. Like, where did you grow up, and what was your like dream kind of want to be? And then did you kind of got to where you wanted to go, or something else?
People always want to hear this story of like when I was a small kid and then I was dreaming of these quadrupeds and already built this with Lego. That's not the case. I mean, to be honest, for me, it was like just one step after the next step. I did what I enjoyed. And when I started studying, I was never thinking that I would be a professor at some point. It just evolved, right? So local gradients. I didn't have like this global optimization from day one.
Right, right. You were going at a time,
Going
and
at
then
a time.
finding what you like.
Trying to see opportunities and trying to catch them. Yeah.
Now, last question. As a professor today, what kind of students do you see? Are they getting better? Are they getting more adept? Are they much more trained as they're coming in? Or how are the talent pools?
People always complain that kids are getting more stupid and more stupid. It's not true. I think we are seeing a big shift. I mean, already in my very short professor career, if I look at the students today and their skill sets when they're entering our research lab versus the ones a couple of years ago, it evolves. And I think that's one of the importance and one of the strength also that we as humans have. We are extremely fast in adapting. I think that's what makes us so successful. So being fast in adaptation, but also adaptation through education and stuff like that. So we have a highly international pool of students, so particularly in the masters. So we typically take some of the top students from our internal bachelors to robotics, and we team it up with about 50% that are coming from abroad to get a very international mixture of students. Also, if you go through our lab, we probably have 30 different nations and all kinds of different background and ethnicities. And I think that's what makes it a very, very exciting environment to work in.
It's funny, you think about Switzerland, small country, but it's highly international and one of the best educational system. And you're doing something really great to impact our lives with using technology. So thank you for your time. Really appreciate participating in the Next Wave Speaker Series today.
Thanks a lot.